So last lesson we looked at finding the surface area of tapered solids and spheres. In this lesson we'll have a look at finding the volume of those same solids. And at the end of this PowerPoint we'll also have a look at finding the volume of composite solids, which is a little bit easier than finding the surface area of composite solids. So just having a quick look at this slide here, in particular these two solids, the cone and the rectangular base pyramid. As always, it's not vital that you memorize these formulae. It's more important that you understand this part here, which says that the volume of a tapered solid is a third times area times height. Okay, so the volume of a cone or of a pyramid will be a third of the volume of the corresponding prism or cylinder. If we have a look at the next slide here, I just want you to pause for a second and go have a look at this video. Okay, so hopefully you've watched the video and hopefully it makes more sense as to why the volume is a third. The video would have shown you that 3 cones fit into a cylinder. So if you have a cylinder and a cone with the same radius and height, then the volume of that cone, or the volume of the pyramid, will be a third of the volume of the cylinder or prism. So just again pause the video and write down these steps so that you can come back and have a look at them when you're doing questions. Okay, so looking at an example here, finding the volume of this cone. So step 1 is always writing down the formula for a volume, and step 2 substituting the formula for A, which is the area of the base. And in this case we have the area of the base is a circle, so substituting in pi r squared for A. Our last step is just to sub unknown values into the formula. So we have that the radius is 3 and the perpendicular height is 12. So subbing those straight in and we get our answer. Okay, having a look at another example, the square pyramid, where our length is 18 and our perpendicular height is 12. So step 1, writing down our formula. Step 2, substituting the formula for the area of the base. In this case it's a square, so we have to sub in L squared. We know that the area of a square is length squared. And our last step, sub the known values into the formula. So we have that length is 18, perpendicular height of the pyramid is 12, and we get our answer there. Okay, the last one we're going to look at before we look at composite solids is finding the volume of a sphere. This one, it is important to memorize the formula or to write it into a bound reference. Okay, so the volume is 4/3 pi r cubed. Don't make the mistake of writing pi r squared. That's a really common mistake that lots of students make. So making sure that when you're finding the volume of a sphere, it's 4/3 pi r cubed. So having a quick look at an example, finding the volume of the sphere, nice and straightforward, writing down our formula. Volume is 4/3 pi r cubed, okay, where radius is 9 centimeters, and just subbing that straight into the formula to get out our answer. And just be careful with all of these that your units are in cubed, okay, so centimeters cubed, we're looking at volume. Be really careful with that. Okay, everyone's favourite part, finding the volume of composite solids. So I said before, it's a little bit easier than finding the surface area. It's very similar to finding the area of composite solids, where you just have to identify the individual shapes and then add them all up. Okay, so writing down our steps here and following them as we do our example. Okay. So finding the volume of this ice cream. We looked at finding the surface area of last time, and remembering when we found our surface area we had to kind of pull it apart. There were bits that we didn't need from the formulae, but again with volume it's a little bit more straightforward. We just need to identify the shape. So step 1, write the total volume as the sum of the volumes of the solids. Okay, so we have a hemisphere Okay, up here we have our hemisphere, and then down there we have our cone. So the volume is just the volume of the hemisphere plus the volume of the cone. So we just need to identify the volume formulae for each part. Okay, so the volume of a hemisphere is half times the volume of a sphere. So looking over here, we have the volume of a sphere 4/3 pi r cubed, and multiplying that by half, or dividing it by 2 if you prefer to do that. Okay, we have that the radius is 5. Be careful, don't use 10. So over here we have 10 centimeters is our diameter. Okay, so our radius is 5. Summing that in, and the most important part here, remember with composite solids, and finding sort of areas, volume, surface area, whatever it is, when you're adding things together, always leave it as an exact answer in terms of pi or in terms of the square root, because later on we won't have any rounding errors if we leave it in that form. Okay, so then looking at the volume of our cone, the formula there, a third times area times height, and subbing the formula for the area, we know that it is a circle, so pi r squared. Now we'll go and write down our values on the side, but we aren't given the perpendicular height. Okay, so be careful with these sorts of questions. Here you've got your slant height, but what we need to use is the perpendicular height. Capital H is always perpendicular height. Okay, so anytime you're given the slant height and you want to work out the perpendicular height, always think Pythagoras. Okay, so over here, just use Pythagoras to work out the perpendicular height. So we've got that one of the short sides is 5. Okay, so the radius of the cone, 5. We have that the other short side is our perpendicular height, it's our unknown, and our diameter is 13, our slant height. Okay, so subbing all of that in and solving for h, we get that h is 12, and then we can write down our values over there. Okay, so the radius is 5 again, and our height is 12. So the rest of it's pretty straightforward. Sub it in, and we get that it's 100 pi. So now that we've worked out the volume of the hemisphere and we've worked out the volume of the cone, step, it's really straightforward. Just sum the volumes to find the total volume. Okay, and this is where we can write out our answer as a decimal and round to 2 decimal places.